Today I'm going to show you how to create a torsional moment or torque load on a model with solid elements in Creo Simulate. The reason this takes a special technique is that solid elements in Creo Simulate only have 3 degrees of translational freedom and do not have rotational degrees of freedom. So I've set up my model already. I have 2 constraint sets. One is a verification set applied to the end of this cutoff drive shaft so that I can constrain it over here and see the pure effects of just twisting on this part without the off-angle effects of the constrained universal joint. I then created a second constraint set to examine that setup as well. We'll go into creating the moment load now. So we want to pick the surface that we want to apply the load to on the solid model, and then go into the advanced section of the load definition. Next step is to change the distribution to total load at point and select a point on the model, whether it be a pre-created point or just selecting on the surface to create a point on the fly to sum the load about. So look at the coordinate system. The z-axis direction is coming out of the model. That's the direction I want to apply my torque. So I'll click in the z field and enter 100 inch-pound force. A good step is to preview this load before you exit so that you can ensure it's in the correct direction and appears as intended, which it does in this case. So I'll hit OK to finish the load creation. And as you can see, I've already created 2 analyses. One is a design and one is the verification. This is to check the motion of displacement in the results window and ensure everything looks as expected. And this one is to get the results that I desire. So I've already run these for the sake of time. We'll switch over to those now. And on the left is my verification data set. So if we look at it from this angle, you can see it looks like it is rotating as desired. And this constrained surface here is holding everything in place. So you can see it sort of spinning about the z-axis as expected. So now I have my design results over here that I can then review the displacements, stresses, and other items of interest on.